sometimes we have multiple functions. In this case, we have f of x, which just means y equals x plus 3. We also have g of x. That's another way of writing y equals x squared plus 2x. They're just distinct functions with their own function input-output rules. We could do h of x, I of x, a of x. We can really use any number in place of f to denote distinct functions. So I wanted to look at some compound functions here. In this situation, we want to add f of x to g of x. So where we have f of x, we can just plug in x plus 3, because that is f of x. Where we have g of x, we can substitute in x squared plus 2x. And from here, we would just have to combine like terms. X squared plus 3x plus 3. In this situation, we're being asked to multiply. Again, we can just substitute in x plus 3 for f of x. And I'm putting that in parentheses to denote that we're going to multiply that expression times the expression for g of x squared plus 2x. Now, some students might be tempted to just multiply x times x squared and 3 times the 2x, but that wouldn't be how we would do this. We would either need to FOIL or use an area model. So using the area model, we can write x plus 3 on top, x squared plus 2x on bottom, and then that way we can multiply each term. X squared times x is x cubed, x squared times 3 is 3x squared, 2x times x is 2x squared, and 2x times 3 is 6x. Combining our like terms, we get x cubed plus 5x squared plus 6x. This is even more difficult. This one, pretty straightforward. We did that in Algebra 1. This one might be something a little bit new, and this is saying g of f of x. Notice that we have the f of x in the place where the x for g of x goes. So what we're saying is we're going to substitute in the input rule, x plus 3, for f of x. So what we could really write here is g of x plus 3. So we're going to substitute in x plus 3 for each of our x's. So we're going to get x plus 3 squared plus 2 times x plus 3. Now again, here it's not going to be x squared plus 9. We have to do this method here. So we can really write that as x plus 3 times x plus 3 plus 2 times x plus 3. So just writing the squared as a product of the same number times itself. So FOILing, I get x squared, outer x times 3 is 3x, inner 3 times x is 3x, out last 3 times 3 is 9. And then I can distribute here, 2 times x is 2x, 2 times 3 is 6, and then we'd have to combine our like terms. So x squared, 3x and 3x is 6x, plus 2x is 8x, 9 and 6 is 15. We won't do a lot of these difficult ones like this in Algebra 2, but you should be prepared for them for your honors pre-calc class next year. And also this is something that you may see on PSAT or SAT.